This is a 1941 Motorola Model 83K1. Here's the chassis out of it. I bought this about 3 years ago, 3 or 4 years ago, maybe longer. 5 years ago. The lady had already restored the cabinet, and I thought that would make it for a much easier. It would make it much easier to fix, but you know, this thing is pretty complicated. Look at this tuner. It's got this motorized tuner and these buttons. Here's the bezel off the front. They're not push. They're like electric buttons. They're not like normally you have like a mechanical push button. This is like an electrical thing that activates the. There's a motor. There's a electric motor right in there. I don't know if you can see that. That turns these cogs. So we'll see if that works. Try to get that working. Anyway, it's pretty interesting. It's a Model 831K. It says it's got 8 tubes, a 3-gang tuning condenser. Now that's interesting that they would put that in the advertising. Do people even know what a 3-gang tuning condenser is? I mean, there it is, right there. There's the 3-gang tuning condenser. But it's kind of interesting that they would put that in the marketing materials, because would the average consumer even know what they're talking about? Anyway, motor-driven feather touch push buttons, 3 bands, American and foreign reception. Talks about the tuning range, the speaker, 9 watts output, push-pull, and the arrow vane loop antenna. There is a phonograph that you could purchase to go along with this. There's the radio right there. You could get a phonograph for $30. That was probably pretty expensive back in 1941. Here's some more materials. Motorola for your home. These are the other 1941 models. So I think I'm going to that's the power cord. I think I'm going to wire in a new power cord and then just power it up just to see what happens. I'll run it through my current limiter. See if it even comes on. It's got a bunch of these old wax capacitors that are going to have to go. I think I counted 14. These are all going to have to go. So if I can get this thing running, I'm going to try to set it up with a Bluetooth receiver. It's got an input for the phono, so it should be pretty easy to wire in a Bluetooth receiver. So anyway, okay, on the schematic it shows that there's a power switch on the tone control. So I've got the new wire wired in there, and I've got the hot lead going to the power switch on the tone control. So it's plugged in to my current limiter. Let's turn that on. I don't know watts. Let's just turn it on and see what happens. Oh, well. It looks brighter in the camera than it just kind of a dim light, so that's good. That's actually good. And we got some tubes glowing here, so that's all good. I have a speaker wired into the speaker jack, So let's turn on the volume. No sound. Nothing. This is the band switch. Well, nothing.
It's one dim though.
Yeah, I mean, that's good. The current limiter is pretty dim. That means it's not like a dead short or anything here. So, let's take a closer look at the tubes on the top. So we got, let's see, that one's glowing, that one's glowing. They're all glowing. All the tubes are glowing. This one here is a metal one, so we can't really see that one. Well, what was that?
White.
Nothing. Nothing at this point. Wow, that filter capacitor right there is really pretty warm. Pretty warm. I mean, it's really warm. That's not too hot. Well, this the mechanism for these push buttons seems to be working, because when I push the buttons, well, it does something. It did do something a minute ago. Let's try this. Maybe just lubricate it a little bit. Yeah. So it looks like that is working. Maybe it just needs a little bit of cleaning and lubrication there. Kind of concerned about the fact that there's no sound whatsoever coming out of the speaker. So I'm still trying to track that down here. It seems like this first tube is... It doesn't seem to be lighting up. It seems kind of cold. And nothing when you plug it, unplug it. You know, you'd think that the output tubes, you would be able to do something, wiggle those, and you'd hear something out of the speaker. There's nothing whatsoever. So it seems like at least this tube over here, this first tube may be an issue. All the other ones are lighting up. This metal one seems warm. That is smoking hot. Let's see, that would be the rectifier tube. It's obviously working. These two output tubes are not doing. I mean, they're on. They're lit up, but nothing from this speaker. So, I'm checking the output transformer. I've got the output tubes out, and then I just have got the on the schematic. The primary of the output transformer is on pin 2 of the output tubes. So I've got the output tubes out, and then my meter hooked across the both pin 2s on the output tubes, and it's 600 ohms, so that seems good. And then on the secondary side, just jumping across the speaker jack, it's what is that? Half a ohm. That seems, at least it's not open. So it seemed like there'd be some sound coming out of that. Okay, if I inject a signal right there on pin 2 of the output tube, which is this right here, I can hear it in the speaker, so that confirms that the output transformer is good. Putting the signal on the grid, which would be pin, let's see, 3 is screen grid, 4 is CG, which is the grid. I'm not sure what the C stands for. I'll put it on pin 4, and you get nothing. So I think my next step is going to be to check some of these voltages and see what we got, because there's nothing getting through the tube. All right, well, we left off, and I was getting no sound, and I was going to check some voltages. But I started looking at the circuit and thinking about this, and there's a field coil speaker in the circuit, and the speaker is actually, the cabinet in the speaker is actually at a different location, so I don't want to bring it over here. Just not enough room. So I found another speaker. I got another speaker here that's got a field coil, and it's just about the same. It checks out about the same amount of ohms. So I wired that into the circuit here. And now, when I turn it on, I actually get a little bit of hum. A little bit of hum and a little bit of scratchiness when I turn the volume. So it is alive. And also I can inject a signal and actually hear it. It's actually pretty loud now. So the output is definitely working on this thing. There's nothing coming from the front end though. So and I see also the pilot lights aren't lighting. And if you look at the schematic here, there's like two. It's got like basically two circuits for the tubes, and one of the circuits has got the pilot lights in it. So I'm thinking at this point there's something going on here. Either one of these, maybe, let's see. If one of these filaments was bad, it would still conduct. So maybe one of these pilot lights is out. No, I don't know. I'm going to have to track this down. I think that there's something going on here in the circuit with these, the second circuit, because the let's think about this for a second. The tubes, the output tubes, are they 42s? Let's see. 80 is the rectifier, and the 42s are the output tubes. Yeah. So yeah, the it's conducting. This is working. This part of it's working, but this part of it doesn't seem to be doing anything, and these pilot lights are out. So I'm going to now I'm just going to try to track that down, see where it's gone wrong here, what's going on with that. So stand by. Okay, these tubes are hot. These lights are out. These tubes are cold. So it seems like it would have to be something with this wire right here, because we got a circuit here. This is working. This is not, and it's a transformer radio. It's not like these would be in series, so it probably more than likely isn't just one of these tubes being out. It's got to be something with this line right here, I would say, coming off of the transformer. So that's where I'm going to head at this point. I'm going to try to test some voltages over here and see what we got. Okay, I've had a little bit of a breakthrough on this Motorola. You know, I could inject a signal basically anywhere from here over, and I could hear it. I could hear the signal. For example, if I inject a signal right here at this tone control, it comes through loud and clear. If I inject a signal on the top cap, right, that point right there, the top cap of that second tube, I mean, you can just barely, you can hear it, just barely. Okay, I've got it on there. I just took it off. I just put it back on. You can just barely hear it. I don't know if that's coming through on the camera or not, but that tells me that the signal's at least getting through from here. I can also put it. I could also put the signal here on this side of the coil and hear it, but not on this side of the coil. So I took a measurement. I ohmed out this coil on this side, and it showed like 75K ohms, but there's a 68K resistor right there. So I lifted the lead on that resistor, and still there was a reading. It was pretty low, like 100 ohms or something. So that tells me that coil is still good. So since the coil is good, I talked this over with my dad. My dad is basically a genius on electronics. He's 85 years old. He actually worked on electronics early in his career. Back in the 70s, he had his own electronics repair shop. He was thinking possibly it could be one of these capacitors, pulling all the, shorted, pulling all the signal down to ground. This one that's right on the antenna lead. This one that goes between the grid and the plate and the grid on the third tube. The grid, or the plate on this, the plate on the second tube and the grid on the third tube, or this one over here that basically is in the kind of in that chain right there. So I lifted the lead of this capacitor that was on the antenna, and there was no improvement. And then I cut the lead on this capacitor that's in between the plate and the grid of the third tube. And I've already done it, so this is just kind of a recreation at this point. And I've just got a chopstick sticking in there, so you can see where I cut the lead right there. I'm going to pull this out. If I inject a signal now into the antenna, basically the antenna jack, I don't know if you can hear that, but it's faintly coming through. Okay. If I take a capacitor now and jump over that capacitor,
different options in different ways.
Try to figure out how to move forward with different options in different ways about the things
I'm just jumping it.
Are you with me on this?
Yeah, still waiting for an answer.
So
She's gone a minute 23 in.
yeah, that's what it was. That capacitor right there shorted. And you know, let me just turn this off. If you look at that, there's obviously something. It looks like the capacitor melted and kind of melted into the lead, because the lead is sticking out of the side. So I mean, obviously, I think I noticed that early on, and I didn't even think anything about it. I should have realized that would be a shorted capacitor. So there, anyway, there you go. That it's just a good lesson to make sure that you, as you're doing your visual inspection of things, if you see something weird like that, then that could be a problem, and it was. So anyway, I'm going to obviously replace that capacitor and the other one, but all these wax capacitors are going to come out of here because they may not be bad at this point, but they eventually will be bad because that's just what they do. These wax capacitors just go bad over time. But I mean, it's working right now with these in there. You know, these are all working. It was just that one wax capacitor that had melted over the lead that was causing the short. So anyway, that's what I'm gonna do at this point. It may take me a few days to get these all changed out. I mean, that one there's buried, but I may just cut it and go over the top instead of trying to go underneath like that. But anyway, that's where I am at this point. So I've got this I've got this capacitor in here just to check it to see what it shows, and yeah, this capacitor now identifies as a resistor, so it's obviously bad. You know, it looks like those leads. It looks like it was made that way with the leads protruding out the side. So I don't know. I mean, obviously it's bad. But it looks like they were never out of the ends. It looks like they were always coming out of the side. So anyway, it's obviously been subjected to a lot of heat over its life. So anyway, it's out of there. This is this capacitor right here. It's a 0.05. It seemed like it made maybe a little bit of difference. Let's see what we got here, if I can get the glare off the screen. Ooh, 149. So, I mean, 149 nanofarads. This would be, I guess, would that be 5? It would be 50 nanofarad if it's a 0.05, right? Am I thinking about that right? So it's up, had gone up in value. It still has a capacitor. This is a 0.47 that I'm going to replace it with. So 41. So it's a little low, but anyway, it shouldn't make any difference. Well, I didn't take any pictures or video of the capacitors after I replaced them, but here's all the old ones I took out. It was really just that one that was causing it to completely be quiet. I usually replace these capacitors one at a time and then power it up just to make sure everything still works. And you know, as I was doing that, I was noticing that it was getting louder and louder and louder with just about each capacitor made it louder. So anyway, there's the ones I took out. I usually, for the most part, replace them with this type of yellow capacitor. There were some exceptions, but for the most part, this kind. I think I got these from Antique Electronics. But anyway, normally I would take pictures of the replacements after I did it, but I just forgot. This project's kind of gone on for quite some time. So anyway, I was anxious to get the chassis back in the cabinet. And here it is back in the cabinet. It's really a beautiful cabinet that was, as I said, was already refinished before I got it. Unfortunately, it looks like somebody shot it with a BB on the glass, but anyway, these, I'm unable to figure out how to reprogram these preset buttons, and actually they don't even seem to be working right now, so I'm not sure what's up with that. But anyway, on this one, if you want to put it on Bluetooth, and I just you know, I just usually just wire these Bluetooth modules into this one. Just goes right into the TV the TV input, and I just make these little labels on Word so that I can remember which direction the switch goes for radio or for Bluetooth. So anyway, there's what it looks like. Got the antenna wired into the antenna input wired into the arrow vane antenna, which it does seem to make a difference. This thing swivels, so it does make a little bit of difference when you swivel that to pick up various stations. And on the back, if you want to put it on Bluetooth, you just flip this switch right here, and then after flipping the switch over to Bluetooth on the back, it's actually the TV switch on the back of this chassis, but I just wired in the Bluetooth module to that. Just hit play on your app, and there you go.
A fiery horse with the speed of light, a cloud of dust, and a hearty hi-yo silver and sunlope.
So there it is. I also made these labels. I just printed these out on Word and taped them on here. It's a little bit cheesy, but just so we can remember what button does what in the future. So anyway, it looks a little cheesy, and probably at some point those will probably come off. But I would like to get I don't know, a Cricut machine or some way to print these things out to some more professional looking labels, but this is it for now. So that's a 1941 Motorola. Model 83K1.
A fiery horse with the speed of light, a cloud of dust, and a hearty Hi-Yo Silver, the Lone Ranger.